All right, today we're doing 1.5. We're going to graph with domains that have been restricted. So we're going to take graphs like of parabolas and we're just going to graph part of them. Okay, that's what it means. We're going to restrict the domain. Before we get to that, there's some plugging in that we need to make sure we know how to do. So this is just a little review. Let's call this Roman numeral 1 review. I need to know, are these the same? Are they different? Are any of these the same? Okay. Is negative 2 squared the same as negative 2 squared? And is that the same as negative 2 quantity squared? Okay. Are any of those the same? Are they all different? Are they all the same? Okay. The first one that I wrote actually is the trickiest. So let's do that one last, because I think we're pretty good with the other ones. What's this going to equal? If I took negative 2 and I squared it, what does that equal? Positive 4, right? This is positive 4. What about this one? Negative 4. Okay, this is the trickiest one. What do you think it is? I gotta vote for 4. Anybody want? You've got to vote for 4. Anybody want to vote negative 4? Okay, this is why it's tricky. The negative is not being squared. Order of operations, what comes first? This really is multiplication. It's negative 1 times 2 squared. Okay, what comes first, multiplication or exponents? Do you know the order? It goes PEMDAS, please excuse my dear Aunt Sally. Did you ever learn it that way? Parentheses, and that's why here the parentheses overrode. Exponents is next, okay? And then it's multiplication. So you're supposed to actually do the power first and then multiply by negative 1. So if you did the power first, you'd be doing 2 squared and then multiply by negative 1, and that would be negative 4. This is negative 4. That's why that's the trickiest one. The negative is not being squared in that case. If I wanted the negative to be squared, I'd need to write it like this, because otherwise it means do the power first, then multiply. Okay, now if you had a function that was, say, x squared, and I asked you to find f of negative 2, okay, is that negative 2, where's that negative? Is the negative going to end up being squared or not? So in other words, is it this case or is it this case? Which one is it? Think about the x squared graph. We know what y equals x squared is, right? When you plug in negative 2, is it positive 4 or is it negative 4? Think about that x squared graph. Here's negative 2 over here. What's the y value, positive or negative? Positive. So we're actually squaring that, right? This is the same idea, that composite function that we were doing. You take this negative 2, you go to the f function, and wherever there's an x, you plug it in, and you plug it in parentheses. Okay? So you're going to, this means this. Take the negative 2 and square it. So we will square the negative away. All right? So that answer will be 4. You're going to be doing a bunch of plugging in like that. So just want to make sure we were good with how to solve that. All right. So the directions for our examples today are going to say this. Sketch the restricted function. And state the domain and the range. Okay, so the only thing new about this today is that we're going to restrict the domain a little bit. All right, here we go. So number 1, this is how it's going to look. All right, the function is going to be given to you, and let's say this first one is negative x, or really I want to think of this as the opposite of x. Okay, this is going to be given, and I love the way this was designed, that we have you find this f of negative 1. That negative 1 is significant because we're going to restrict our graph. We're going to graph f of x if x is greater than negative 1. Graph f of x if x is greater than negative 1. So what you'll find is this little guy right here that you're finding, that's going to match up. Those two are going to be the same. And there's a reason for that. Ultimately, where we're going is the next lesson, piecewise, And you want to always plot that point. This point right here, you want to figure out where it is. And that's what it's helping you do. Okay, so let's find that first. This is go to the f function, okay, wherever there's an x, in parentheses put -1. So there's already a negative there. You need to carry that down. That negative's still there, but now this x is going to be -1. That's how you evaluate that, okay? So whatever this is, put it in parentheses where that x is. So you have a double negative, making it +1. That's a point. -1, 1 is going to be a point that we're going to sketch. And you know what we're going to do? We're going to make it open or closed based on right here if there's an equal sign or not. If there's no equal sign, what should it be? Open or closed? Open. Yeah. So we're going to sketch an open circle at -1, 1. Okay, and that's a point on this graph. -1, 1 is a point on this graph. All right, go ahead and set up an x and y axis. And I would immediately plot that point that you just found, -1, 1, and put an open circle there. And now my graph is going to extend from that. That point actually is a dividing line, and I'm either going to graph to the left of that or I'm going to graph to the right of that. Okay? It depends on this inequality. What would you describe x is greater than -1 as? To the left of -1 or is to the right of -1? To the right. We're going to graph the portion of this line which is to the right of this. Okay, so now we're going to go to our rules. This is a line, yeah? How's it been shifted? How much to the right? Nothing, right? How much up or down? How much left? Nothing. It hasn't been shifted at all. So it goes through 0, 0. Now, you're going to plot 0, 0 only if it's in this restricted domain. Okay? So, right here is normally where this graph would have started, right? The x-coordinate right here is 0. Is 0 bigger than -1? Is that true?
Yes.
Yeah, so that's a point we're going to plot. So I'm going to plot that point. And then what we would have done is we would have done the slope from there. Yeah? And the slope in this case is -1. So we would have gone down 1 over 1, down 1 over 1, and we would have plotted this line. Okay, and here's the key, you guys. This is where I'm going to stop, but then I'm going to go to the right. I'm going to plot this line. I'm just going to keep going right, 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 and down at the same time because this line's going down. Okay, so I graphed y equals -x just for values x is greater than -1. Okay, let's do another one. All right, for the second one, the function is x squared. What's that graph? Quadratic. That hasn't been shifted at all. That's our parent function, okay? But we're not going to graph the whole thing. In this case, -2 is going to be significant. And I want you to graph, I'm not going to write graph anymore. We're going to graph f of x if, in this case, let's go x is less than or, no, let's still go greater than, sorry. Greater than or equal to -2. X is greater than or equal to -2. Okay, so we're only going to graph the portion of that quadratic where x is greater than -2. Step 1 is to find f of -2. That is, go to your f function. In place of x, you're plugging in -2. Keep that -2 in parentheses, yeah? So it's going to be -2, and then it's being squared because it's x squared, which is 4. The very first thing you're going to plot is the point -2, 4, and you're going to figure out if it's open or closed based on, is there an equal sign here? And there is. So what's it going to be? Closed. We're going to make a closed dot at the point -2, 4, and that's going to be the dividing point of my graph. I'm either going to graph everything to the left of it or everything to the right of it. Okay? All right, set up your x and your y axis and plot that point. Oh, shoot, I messed up. Okay, sorry, there's an extra little point here. We're going to ignore that point, okay? I can't fix it at this point, so I'm going to leave it. All right, now that's my dividing point. So this guy right here is my dividing point, and I'm going to either do everything to the left of that or to the right. Would you describe x being greater than -2 as being to the left of -2 or as being to the right of -2? To the right. Okay, so I want to pick up the parabola and I want to go to the right. Now I'm going to look again and see this. We said this hadn't been shifted at all, right? If it hasn't been shifted, then it should be right here at 0, 0. Is that in our domain? When x is 0, is 0 bigger than -2? Yeah, so that is. So I'm going to go ahead and plot that point. If it wasn't, I wouldn't actually sketch it. I would just put my pencil there. Okay? And then from here what we did is we went up a over 1, right, in both directions. Up a over 1, that's in my restricted domain. And up a over 1 this way is also in my restricted domain. Okay? And then this is all greater than -2, so I know I'm going to have all that portion of the graph. But on this side, I'm going to go through here, but then I'm going to stop right there. Because that's the stopping point, or this, in this case, the starting point. That's the significant point. And I'm only graphing the parabola to the right of it. Okay? If this had been x is less than -2, I would have just put my pencil here. I would not have sketched any of this. I would have started right here and then picked it up and just done that little tiny portion of it. You know, just this that's shooting up. Yes?
Why was it closed again?
Why is it what?
Closed.
Okay, because it's greater than or equal to -2. So if it has that equal sign, you're going to make it a closed dot.
And if it doesn't, it's open.
Then it would be open. If it just said greater than -2, it would be open. Okay? Let's do it. What did I forget to do on these two problems? Forgot the domain and the range. Okay, can we write that? The domain. Domain, x values or y values? X. X is left and right, okay? How far left did we go? Oh, it stops, right? -2. So -2, and does it hit it? Was it solid? Yeah, so what do we put? Bracket. How far right does it go? Keeps going, right? Infinity, that's our domain. Okay. Range is the y values. What is my lowest y value? 0. Does it hit it? Yep, so bracket. What's my highest y value? Infinity. It just keeps going up and up and up forever. Okay. Can we just look back for a second at the number 1 and put the domain and range on that one? Domain. How far to the left does this graph go? What's my lowest x? -1, right? Does it hit it? No, so parentheses, right? And then how far to the right does it go? On and on and on forever. Okay, range. What's my lowest y? What's the lowest this goes? -infinity, just keeps going down, right? So -infinity is my lowest y. What's my highest y? 1. Does it hit it? No, so we'll put a parentheses. Open circle means parentheses, right? All right, let's try number 3. For this one, I want you to graph f of x equals negative absolute value of x. I want you to find f of -2. And then for this, I want you to graph f of x if x does not equal -2. So not an inequality, I mean, yeah, not a less than or greater than, but just that it can equal -2. Okay, so let's first figure out what it is at -2, find that, okay. If I plugged in -2, what's the absolute value of -2? 2, but then I've got a negative in front making it -2. Okay, so this would be -2. I'm going to plot the point -2, -2. This says not equal, so what am I going to make it? Open. Yeah, you can put an open circle there. Okay. And actually what this means, if it just says x doesn't equal -2, it says graph everything else except for that point. So we're going to put an open circle at that point, but we're going to graph everything else just like it is. Okay. So set up your x and your y axis. Plot -2, -2 with an open circle. And then we're going to figure out the rest of the graph. We know the graph would go through that point. If they didn't have that exclusion, it would go through there.
I believe the -2 in parentheses because wasn't there with the -8 3 down?
Wait, say that again. -2?
So like the -8 that you marked on the last problem,
Yes, okay, so we squared it away. All right, so let's think about that. So if you plugged in -2 here, you'd have this negative would carry along, and then inside the absolute values, you'd plug in the -2. That's the same thing. Absolute values are kind of similar like parentheses, right? When you take the absolute value of that, that would be +2, but then this says multiplied by -1 to make it negative. -2. Okay, this is the absolute value graph. Shifted how? It's not, right? So it's going to go through 0, 0. And this is saying graph everything. So you're going to graph 0, 0. And then from there you would look at the slope, right? We'd go down 1 over 1. Look, down 1 over 1. Sure enough, it's going to hit that point. It should. We will continue on beyond that, okay? And we're going to go in the opposite direction too, because we know a absolute value graph makes a V. Wow, I don't think I'm lining those points up very well, but you got the idea. So we're going to make a V, and we're going to graph everything except when x is -2. So that means you're going to do the right-hand side here, and the left side you're going to go all the way up to where x is -2, jump over it, and then continue on beyond it. That's how you would exclude a single point from a graph, okay? Just say x can't be that point. Kind of cool? All right, try this one. Number 4. Oh, domain. Thank you, thank you. Okay, domain. How far left does this go? This keeps going here. It's going down, but it's also going left, right? So it keeps going all the way out here. -infinity and -infinity, -infinity. Okay, that's a problem spot. There is no value for -2. So how did we write that? And then it's going to pick it up on the other side of it, and it's going to go all the way. -infinity to -2 with a parentheses. Good. And then union, then we'd want to pick it right up at -2, right? And go all the way to infinity. Can you tell me again, why can't I let that be -1 and pick it up from -1 and put a bracket? Okay, yeah, you got all those points between -1 and -2 that you would have not included. Okay, so that's how we exclude -2. Okay. Oh, and the range? What's our lowest y? -infinity, right? This goes down, down, down forever. Okay, now as I come up, there is a problem spot here, except covered on this side. So it's going to go all the way up until we get right here, which is 0. Bracket? Okay, for this next one, I want you to sketch f of x equals 4. I want you to find 2 points, -2, f of -2, and f of 5. Okay, because we're going to sketch f of x if -2 is less than x is less than or equal to 5. Okay, trying to figure out what this would look like. Okay, so this looks a little bit tricky because we don't have an x here. And this f of -2 says go to the f function, and wherever there's an x, plug in -2. If there's nothing to plug it into, what do you think f of -2 is? If you had to guess. What do you think the answer to that's going to be? And then we got to figure out what f of 5 is. How do we do that? Any guesses? Make a guess. What do you think, Nick? Make a guess.
I don't even know the question.
I got to figure out what f of -2 is. The function is defined to be 4. So what's f of -2? What do you think it is? -4. Okay, got to vote for -4. Any other votes? Any different ideas? No idea? No clue? Okay. Tell me, you guys, if I was just graphing this whole thing, y equals 4, that's what this is. What does that look like? Okay, you're tracing it here. Horizontal line up at 4. When x is -2, what's the y value then? What would the y value be for that? So if I sketch the whole thing, it'd be up here at 4, right? So what this is asking is when x is negative 2, what's the function value? So at negative 2, what's the function value? It's 4, right? The y value is 4. Yeah, so if there's nothing to plug in, it's just that constant. So what is it at 5? When x is 5, this is saying what's the y value when x is 5? It's still 4, right? Everything's 4 on this function. Okay, now we have found 2 points. We found negative 2, 4. This is going to be a point we're going to plot, and we're going to figure out if it's open or closed based on right here with the negative 2. Is there an equal sign with it? No. So that needs to be open. And then the other point we're going to plot is this 5, 4. That's, you just list it right here, right? 5, 4. And then you look at the 5. Is there an equal sign? Yes. So what's it going to be? Closed. Okay, so those are the 2 points you're going to graph first. So set up your x and your y axis. I know that it has to move way up, so since I'm running out of room, I'm going to drop my x-axis down. And I'm going to plot negative 2, 4. And I'm going to make it open. And then 5, 4. And I'm going to make it closed. So those are 2 points that my graph has to go through, okay, or touch. The open circle it's going to touch, the solid dot it's going to go to, okay. And then I'm going to look at the graph, and we kind of already talked about this. This is y equals 4. It's a horizontal line, okay, but we're going to stop right here when x is negative 2, or we're going to start there and we're going to stop when x is 5. So you just got a straight line, connect it, that's it, that's the graph. Okay? So if it's just a horizontal line like that, you just got to put an open circle here, closed dot there, and you got it. Okay? All right, let's figure out domain here. Eros, can you tell me the domain? What's my furthest to the left x? Negative 2. And what's my furthest to the right x? I think it's 5. Is it? Go out to 5? Okay, does it hit negative 2? No, so what do I put? Parentheses, and what about 5? Bracket. Good. Okay, what about my range? How did we do that? The brace, right? Yeah, the brace, and what's the only y value that's included here? 4. Does it matter that there's an open circle right there? Does that matter? No, you got all these points where y is 4, so it's included. All right, let's try another one of these. Okay, let's try this one. F of x equals 2 to the x plus 1, where the plus 1's not up there with the x. Okay. I want you to find f of negative 2, and I want you to find f of 3. So again, when you're given 2 like that, we're going to go between those 2 points. So we're going to sketch f of x if negative 2 is less than or equal to x is less than 3. Okay? So those are going to be 2 points we're going to find right away. We're going to figure out if they're open or closed. All right, are we ready? First thing we're going to do is plug in negative 2 to this function. That means plug in negative 2 to this x. So let's work it out up here. We'd have 2 to the negative 2 plus 1. What's 2 to the negative 2 equal? What does it equal? When you have a negative exponent, you're supposed to flip it upside down, right? Make a fraction. This would become 1 over 2, and then you switch it to the positive. So that's 1/4 plus 1. You know what? I'm going to write that as 1 1/4. Because I'm sketching, that's easy. I'll just go 1 and a little bit above it. It's going to be 1 1/4. Okay, so this is 1 1/4, or if you like 1.25, you can do that, or 5/4. Okay, let's find f of 3. Plug 3 in. So we'd have 2 cubed plus 1. 2 cubed means 2 times 2 times 2. What does that equal? 8 plus 1? 9. So f of 3 is 9. Okay, so the 2 points we found are right here. Negative 2, 1 1/4, or 5/4, open or closed. Okay, look at the negative 2. Is there an equal sign with it? What were you going to ask?
2 cubed isn't 9 plus 1 is going to be 10.
2 cubed is 8. 2 times 2 times 2 would be 8, right? Okay, the other point is 3, 9, and can you tell me, will it be open or closed? Is there an equal sign with the 3? No, so it's open. Okay, so these are the 2 points you're going to plot right away, and then we know the graph's going to come somehow go between those 2 points. Okay, so set up your x and your y axis and plot those 2 points. Let's see, I need to go up to 9. I'm going to drop this down again. Oh. It's supposed to be okay. All right, we good? Got those points plotted? All right, so we got solid at -2, 1 1/4, open 3, 9. Now let's go to the graph and let's apply our rules, okay? So go to the function, 2 to the x, exponential, right? You know the shape of it. Shift it how? Up 1. Okay, now when I shift the exponential up 1, what's my starting point? Where does it usually start? 0, 1. Okay, so this is normally where it starts, but if I'm going to shift that up 1, that means it's right here. That is between those two, so I'm going to plot it. Okay? And then actually, we kind of know what this should do, right? You know it's exponential. So you kind of got the shape of it. Just go from your starting point, go through that one that we plotted there, and then boom, up to your ending point. You got it. That's all you got to do. We know the graph looks like that. Okay? Kind of cool? For the domain, Kirsten, can you help me out with the domain here? What would it start at?
-2.
And where would it stop?
3.
Bracket or parentheses with the -2? Does it hit it? It does, right? So that's the bracket, right? This guy's the bracket. And then here, it doesn't hit it, so that's the parentheses, yeah. Melanie, can you help me with the range?
I put 1.
Because actually, where was this? What was this y value here? 1 1/4, right? Do you want to write it as 1.25 now, or do you want to leave it as 1 1/4? Doesn't matter. I'll just leave it as 1 1/4. Did it hit that?
Yes.
Okay, so bracket, and then my highest y is up here. What was that?
9
With the parentheses, yeah. Okay, on a scale of 1 to 4, can you tell me where you're at, please? 1 is I got this, 4 is I don't. Okay, show me, please, where you're at. Okay, so I'm going to do one more. You guys tell me quadratic or absolute value or exponential. Pick. Exponential. You want to do another exponential? Okay. Let's do one exponential then. Let's call it f of x is, let's do a base 3. How about that? And let's do a, let's go a +1 up in the power. Okay, let's do that shift. Let's go from, so what's that going to do? Shift it left. Let's go from -1. So let's find f of -1. That would be interesting. And let's go to 3. Okay, so we're going to sketch this graph. We're going to go from -1 is less than x is less than or equal to 3. Let's do that. Yes?
Can you explain how to do that better? Like going from 3 to x plus 1 and then getting like f of -1 equals
This and this.
something.
That's all going to be given.
Oh,
This is all going to be given. So this is the problem that you're going to be looking at right here.
well, how do you get the number? Because you always put like f of x or f of -1 equals
Those.
something.
That, again, that's given. Okay, but how do I find f of -1? Like, how do I do
Yeah.
that part of it? Okay, yeah. All right, so what this means is go to your f function, plug in -1 for x.
Oh, okay.
So you're going to go right here and you're going to plug in -1. So when I do that, I'm going to work it out over here. Plug in -1, I'd get -1 plus 1, which is 0, right? What is 3 to the 0 equal? 1. So that's right here, 1. So my coordinate right here is going to be -1, 1.
Oh, okay.
And I'm going to figure out if it's open or closed. Down here, if with the -1, is there an equal sign? No, so I'm going to make it open. So this one's going to be open. Okay. Then for this says go to your function, plug in 3 for x. Okay. So if I plugged in 3 for the x, I'd have 3 to the 3 plus 1. That's what I'm doing, right? Which is 3 to the 4th. Anybody know what 3 to the 4th is? 81, yeah. Okay, that's going to be a little difficult to sketch. We're just going to go up to a point and call it, say that y value is 81. Okay, so that's way up in the rafters. I probably should have stopped at 2 instead of 3, but okay, so we've got the point 381, which we're just going to kind of fake on our sketch here. Open or closed? Closed. All right, set up your x and your y axis and plot those 2 points. But let's just say that 81's right here. Okay, we'll say 81's right there. So at -1, 1, which I'm going to put way down here. Oh, that one was supposed to be open, so pretend like that's open. And then at 381, we're going to say that's closed right there. Okay. So we've got a couple points. On the test, it's going to ask you to show 3. So we've got 2. So the third one you're going to get is, let's move that starting point, okay? Which actually I think we already did, didn't we? This is shifted how? Left 1. 0, 1, which was right here, shifted. That is it. So we need one more. So what if we just either plugged in 0, or we could use a little trick. If the base is 3, to find the next point, what did we do? Up how many? Up 2, 1 less than the base, right? So if you went up 2 over 1, this would be the next point. Or you could plug in 0 to get that. Okay, so there we go. We know this is exponential. It's just going to shoot up like that. Okay. The last type of problems that they're going to give you is they're going to ask you to evaluate. Okay, so I'd like to show you how to do that. We've kind of already been doing it, honestly. Yes. As soon as this is the last example. Okay, so graph, actually we're just going to evaluate. Evaluate, and this is going to be the first on this worksheet, so it's kind of a nice order here. Am I on number, what number am I on, you guys? 7? Okay, so given this piecewise function, actually hang on just a second. Okay, I'm sorry, somehow I switched my order here. I'm sorry, I went to the wrong thing. This is the next set of notes. Scratch that for right now. The only other thing you're going to be doing is writing the equation. Okay? So given the graph, write the equation. Evaluate, we're going to do that in 1.6 notes. I somehow switched my notes here. Okay, so given this graph, write the equation and write the restriction. Set up an x and y axis, please. On your x-axis, go from -2 to 5. On the y-axis, count up 6. At -2, 6, put an open circle. 3, 1 is going to be a point that you're going to be able to see pretty easily. And 5, 3 is a point you're going to be able to see. And it's solid. And then it's going to kind of look like a check mark backwards. Okay, so this would be given. And you're asked to write the equation and the restriction. okay? So you have to know by looking at that what that is the graph of in general. Is that a line? Is that an absolute value? Is that a quadratic? Is that an exponential? Which one is it? Absolute value, right? Okay, so it's an absolute value. So the first thing that we're going to do is we're going to figure out how has that absolute value been shifted and what's the slope. All right? So if I started to write this, I would write f of x equals, to find the slope, which goes in front of the absolute values, pick 2 points that you obviously can see. These two I can obviously see. Find the slope on them. Now it'll be on a grid, so you'll be able to count. But if I counted here, it looks like I went up 2 over 2, based on my lovely spacing there. But if I go up 2 over 2, what's the slope? 1. Okay, so there's a 1 there. I don't really need to write that. Then I'm going to put the x here, and I'm going to figure out how it's been shifted. Now with the absolute value, it's the bottom of the v that we shift, right? It's normally right here. It looks like it's been moved over here, which is shifted 1, 2, right 3, up 1. How do I get a right 3 shift? Minus 3. Close the absolute value. How do I get an up 1 shift? Plus 1. Okay, so that would be if I had the whole thing, right? But now it's been restricted. It looks to me like this x-coordinate right here is -2.